drilling, and obviously, as we've seen in urban environments, it's just tight footprints, limited access. But I think the more significant here that I want to jump right into, and we're going to start with
I'm running the US operations of Rototec, and we started our business in US in where we can drill. So been doing in Sweden for a long time. Project called Christ. Think is installing this. Here, then we have a were angled under the this small site. For bedrock. So if you think of the boreholes, traditional layout for this project. More track-mounted drill rig. Single boreholes, test bores. You can get more short distance between boreholes, then you're to 1,500 feet if you want to. $1,050. Diverter system. Can to collect cuttings.
Very short intro into and how do we coordinate with our drilling contractors?
Sergison. I work for Salas. So very familiar with the geology. Which has really opened my eyes to the way test bores or trying to price. It's really what I know, so I'm starting to just learn more about how everyone else does things, how other drillers do things, construction managers, and even, coming from and I mean a bit about Salas O'Brien. We are a full-service engineering firm. We do a lot of geothermal as well, but I think we've grown. We've almost doubled since I started working here 3 years ago. But I'll just run down them quickly. I think like a 28-story apartment building, but we installed, I think, 62 bores. Allied drilled them underneath the building before it went up, and it's a hybrid system, so we were able to qualify for all of Con Edison's incentives to help bring the total cost of the project down. But that was very intense starting to drill that because they had to bring the drill rigs down into the excavation. A lot of problems to work through on that project, but at the end it's fully operational now and they're occupying the building. So that was an exciting one. And then we're doing a Lafayette development for L&M. They're putting up about a dozen buildings in East New York, kind of near JFK. And American Well has done most of the drilling there. I think you got 300 bores in there probably now. And you don't even hit bedrock there. I mean, Garrett could probably talk about that a bit, but basically it's a bunch of sand and gravel all the way down to 500 feet. So good, easy drilling there. I think drilling is not easy, but there it's a little bit easier maybe. And then these two bottom ones for New York City are extremely small. So Soundview Rec Center, New York City Parks, and New York City DDC. They're putting up a new rec center in part of a Soundview Park, and they really want to do geothermal. So I think it's only 24 boreholes, but it's right on the water. We're just about to do a test bore there. I love New York City, but they are putting a lot of stuff on the driller. They want site security, site fencing. They want frac tanks because they don't want to get a sewer discharge permit for any water that they might hit. So yeah, we didn't even start that one yet, and it's been a little more challenging to, honestly, to get drillers to bid on it because the city puts a lot of non-drilling things onto the driller. And then, yeah, Rosedale Library, it's even smaller. It's a little library in Queens. It's existed for a long time, but they're expanding it. And they want to do just 8 boreholes underneath the expansion before they add to it. And man, it's like some of the tiny projects just take so much work. So even just for 8 bores, it's just taken a lot of planning. New York City's, they want to do geothermal, and we want them to do it too, but I feel like there's just a lot of, as you can imagine, some red tape and processes that make geothermal a little harder to install here than you'd think when it comes to, some of the city stuff. And then in Jersey, both projects for Elcor, both, I think about 28-story apartment complexes, but both of those bore fields are under the building. I think Hoboken is 66 bores to 850 feet. It's right on the, right in Hoboken Yard, so where all the trains come in. There's the PATH train that goes under the Hudson and goes over to Manhattan. And, it was very, very hard drilling in general, but just basically a lot of underground stuff that you have to coordinate ahead of time to make sure, you're not going to drill through the tunnel or anything like that. And you also got to put the building on top of it. So, yeah, Hoboken, I think drilling is nearly complete there. And then 107 Morgan, that's, I think, about 100 holes to 850 feet. And that's going to start up, I think, in the spring. And, we did extensively coordinate that with the other utilities, but since it didn't start drilling yet, I'm sure it's still, there's always problems no matter how well you plan. And then I just have a few photos from some of these projects I've mentioned. I tried to keep them OSHA, within OSHA, safety guidelines. So everyone's wearing a hard hat. I don't think there's any liability issues with these photos. But yeah, I tried to pick some of the ones that are a little more, you can just see a lot that goes on site. I mean, the top left, that's from Alafia, a lot of protection, that's just a few feet of PVC, 6-inch around the loops after they're drilled before they're tied in, just to protect them from all the forklifts and stuff going by. People think it might just be a hose sticking out of the ground. They don't realize it goes 500 feet down. And then, yeah, we had to put sleeves in the rebar in the middle. They needed to get the building up before the lot of kind of infield coordination just to make sure they got those conduits in that needed to be encased in concrete, and you still have to get the geothermal where it needs to go. And then these 3 pictures, I think the one on the left is that 247 North New Rochelle job. The guy's standing on rebar trying to get that loop in the hole. Middle one is Hoboken, so on the left side of that photo, that's an active rail station. On the right side, they have the entryway to the PATH train. And then I think on the right side, that's Jersey City.
Next, we have Scott Adelsbach, who perfected this in Chicago, the rig-in-the-box solution, and then has brought it here and has had great headway. And it's great to have you here to explain how we can do this in very small areas.
Thank you, Brock. This just press forward, I
Yep.
guess. Okay. Hello, everybody. I'm Scott Adelsbach from Chicago. I live in Chicago. Chicagoland Geothermal is my full installation company in the Chicago area. We're a full turnkey installation, including drilling. I developed a machine in basements, a lot of just residential basements. We basically took care of an issue where we didn't have much space available outside in the yard space for drilling and during projects, so therefore we had twice the amount of space inside of a building versus outside, as well as more space for access. Chicago's a little more open than Brooklyn, but that's what stemmed the creation of what I call rig in a box. Very hokey name, but you'll remember it. again, full turnkey installation projects along with the drilling. If you see, there's some pictures. There's one picture. And it's a townhome, and that's all we're doing is townhomes in the Brooklyn space. The machine's all electric, and what it does is it's answered a lot of problems that Brooklyn would have for doing a geothermal installation, as far as parking, unloading, transporting your machine, everything else. We were able to fit everything in this van that you see on the upper left here, and the entire drill rig system fits within that van, and then unloads to the sidewalk, and then we transport it through the home, either through the house to the backyard or through the house to the basement. Then we reassemble the machine in location for drilling. It is all electric, which keeps it quite quiet. I think I have some videos at one point, so I won't talk too much. Oh, on the keyboard, I'm sorry. Okay. A little closer shot of the first one. This is in the backyard. You can see the system. The machine itself breaks down. In this particular project, we did 100-foot boreholes, 8 of them for a 5-ton system. Hand trench, that's the one negative to working in Brooklyn. You can't get an excavator out to do trenching, so we hand trenched 4-foot trenches to make our horizontal connections, and then brought that into the basement, which is a 5-foot tall basement. Another same picture, same area. There's 150 feet of pipe on the machine there, but it's a mud rotary system that we're using here, which we pretty much have to do to keep it quiet. I don't know if we can do down a hole hammer with an air compressor and keep the neighbors happy. Here is a video. How do I play the video? Oh, it is a video?
There should be a video, that should play.
Okay, automatically?
Should just click on it.
Enter?
Let's see what.
Okay, there we go.
There we go.
What did you? Well, there it goes. So an example of what I think is a typical Brooklyn street, far as I can tell so far. This is the project, and it's challenging getting a machine through, getting anything through these couple of 90-degree turns to get through into the building. This is just an example of what we had to go through to get our equipment through the space. This is a modular system. You can see the electronic components, and we are actually using the buildings. We're actually working. We're on a lot of construction equipment here, but we're still managing to do it all. The machine's quite small. We actually had, what's great about this is the neighbors were more impressed and interested in what we're doing versus being upset and angry about the noise. We can talk real quietly just between us here and still actually hear each other even when the equipment's completely full-fledged running on full speed. So it answered the problem with the noise that I think is going to be a major issue with any, down a hole hammer or any large machine within this tight urban environment. Let me go to the next. And then this is another project we've just, this is about 3 or 4 months ago, drilled in the basement, and this is just an example we did 5 boreholes, 150 feet down, and you can see where, the electric is tied into the main fuse breaker box. Well, we need a minimum of 100 amps to operate. But again, tight space to get into, but the machine we can bring it into probably any building or any basement, as long as we have at least a 7-foot clearance in the basement. But opens the door for quite a few geothermal installations throughout Brooklyn and beyond. I believe that is the last of it. So thank you very much.
It's right. It'd be brilliant if I had plugged in the clicker. So, I want to introduce Soren So, but I can't speak into putting a USB in upside down at the right time. Anyway, my favorite Danish Aussie, but Soren came to New York, Brooklyn 2 years ago or 18 months ago, and then was in Saratoga, but an amazing knowledge share, and this piece of equipment is going to change how we're doing this. We also have several other coil tubing experts in this room right now, so we're seeing the influence of coil tubing not just being boutique and maybe one or two companies, but we're going to see a stronger acceptance to this, and it's exciting times.
Thanks, Brock. Let me start by saying that the ground source heat pumps are not widely adopted in Australia. However, it is steadily growing, and there are some, you can say, larger developments with example of 750 homes around Sydney. Even though we're not drilling a lot of geothermal in Australia, we're drilling a lot of numbers with coil tubing for mining across both hard rock and drill rods for the drilling. All of the methods today, mud, rotary, air hammers, and sonic, and what's used, are typically using 10 or 20 foot long coiled steel as the drill string. And just to be clear, and the drilling progresses the coil rig continuously. Unwind this tubing into the ground and straightens it. Using hydraulic driven chains and gripper blocks, and this injector delivers the right force. Carrying the cuttings are processed and recycled and reused again and again. That reduces water use. Drilling operation, there is no one touching any drill rods. The operator is positioned a fair way from the drilling functions on the rig as well, and you can of course run darts or casing for installation. We can New York. It's a relatively sand, clay boulders, and intermediate and hard rock bands, and the drill until this year been is actually the first time we are talking drilling 400 feet holes repeatedly, and we, if you ask feet in an hour of drilling. maintain the borehole stability. That takes less than 6 minutes to get. And we're using a stinger, as we call it, and a stinger winch, and we keep highly automated, and you pack the rig up by just pushing a button. To drill again. Rapid upskilling of the conventional drillers with drill rods to transition into use. That when you're starting to drill, attached to those so I think that's the end of my 5 minutes.
Soren, it's pretty significant if we think about footage rates when we think of what fuel burn is per hour. Compact, the same as how the Rototec or the rig in the box method. This is great. Now we're going to hear from Jackson. I hope he doesn't say anything colorful.
Oh, I'll try not to. When they asked me to be on this panel, I'd be drilling in the Hamptons in a country club atmosphere. Try drilling 5 blocks in Brooklyn over here. Try to get your equipment onto the site. Sometimes we got guys loading trailers up at 2 in the morning. Utilities, with GPR on the site. We're looking where the water tunnels are. Hopefully, good engineers will give us a hand here. Subways. Next thing we're looking at today is it's challenging with the piled it up, left it to the builder to take care of, and we very easy to go. A hole about maybe 18 feet. See how close we are. And if you look at this site, we got to ramp ourselves in. We're lucky where we are because we're pretty in the city. And New York, it's not just one person. Geothermal geothermal is the heart of the heating of this building. It doesn't come that way. They know they need foundation piles to build the is going on. So that's the one thing we're trying to emphasize. This was the end of the job here with the manifold. A little complex. The reason on this side here, we had mechanical room and say, hey, make it work. Bring 16 lines in and see what you could do to get it in there. And as a contractor, it's our job to make it work. It's the end, that's what it comes to. Demobilize. So it's not, usually we go drill a job, you go drill your 80 holes, you're in a cut, you just go, you pipe it and everything else. Once again, logistics of what you're gonna get in. Challenges of drilling. So we had a rig there. Gave us a new rig, brand new, never used. We put it on the job site and you say, hey, brand new rig, looks great, shiny, we're all ready to go and drill. Hook the mud pump up. The motor seized on the mud pump. You're like, oh. So this job is what I call the devil's going at me every day. It just comes up and reaches out of the ground and says, get out of here. So this is one of the most difficult jobs we did. I'll give you a little about this. Technology here, we went with PDC drilling. The reason we did PDC, discharge permit the city makes you get, and it's only a test hole. So we did this job, we went 650 feet. I don't like people that go to job sites, oh, this problem, this problem. To fix this problem for you. That's what will make drilling technology and everything go forward faster. Don't be no, 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 no. Say, hey, what can we do? Interesting, to tell you the truth. I know we have other drillers that are drilled in here, and they would probably $1,000 right there to take the soil out of this job site. $26,000 to get this soil out of there. And you think about changing the laws, and you think about being over-regulated. It's like, from the drillers from mine, it's like, look, you're pricing yourself out from doing this stuff. Come and get a sense. Aren't the guys on the ground like me drilling? There ain't the family business. They're the big people. Like, they want to price this to the point that the little guys can't do it. You need the little people to help. Never get another job from an engineer here, but okay, and that's the last slide, and I'd like to thank my wife, She did the slides.
Thanks, Garrett. And you're absolutely right. You know, from engineers to developers to everybody in this room, regardless of what we believe, we are discovering the unknown together. And that's how this drilling is going to work. And as we start talking cost overruns from drilling, there is a qualified contractor that has a means and methods that will work. We have to trust in that process and collaborate better. And as Garrett mentioned PDC today, polycrystalline diamond compact, not pretty damn costly. It's what I usually was readily available to decrease cost of using downhole hammers and diesel fuel. It didn't get widely accepted by the oil field until the late 90s. And then so I'm going to use questions off my phone, so John, don't be upset at me for now. I'm not doing an email. But I also, I respect your guys' thoughts and what you want to talk about today. So if there's somebody that has something right now that we need to address, let's do it. Put you on the spot.
Hey guys, first off, thank you all for being here. This has been a really educational conference. My name's Colton Curtis. I'm with Tishman Speyer, based over in Manhattan. And you guys all talked about some really great solutions to a lot of problems that I've heard come up a lot over the weekend, not the weekend, but over the last 2 days. I'm just curious, what do you think some of the biggest challenges are to implementing these solutions on a wide scale, especially in a constrained place like Midtown Manhattan, where I am working a lot right now? Thank you all.
Kicking us off, Kim? Take it to Garrett. To Tony.
Manhattan's very challenging. As you know, you look at the buildings in there. I mean, I know Brightcore's come up with solutions of inside the building trying to drill, but the economics of it is expensive. I mean, people think rock is easier drilling. You know, at the end of the day, you get the case in the rock, it's easier. So you need space to a sense, or maybe come up with different solutions of your drilling. Maybe the Rygan gives you more tonnage. Maybe coming up with a different kind of loop that gives you more. There's different things you could try. But I mean, you go to Manhattan. I've drilled inside of, you know where Jane Street is over there. I've done 16 holes. They took the roof off of the building, did 4 with the mini rig. I mean, 500 feet. It's complex. Try to get a truck in there. Try to get a service truck in there. It's a complex environment. Can it be done? Yes. But look at all the subways, the water tunnels. Look at the utilities. It amazes me when I look at the utilities under the street that you have there, like in the 1900s, and there's still. It's amazing what they did. So if they can do it in 1900s, I hope we can do it in the 21st century, is what I would say.
Dan, Kim, any thoughts? Put you on the spot.
I mean, everything's just built already. I mean, similar to what Garrett's saying. Like, there's so much. There's utilities you know about, and then there's a bunch you don't know about. There's so many clearances to worry about. Even if it is a mini rig, will it even fit? Do you have to modify the building to get it in there? You know, depth limitations, assuming it is a retrofit as opposed to like a new build. But even new builds are hard in Manhattan, and that all has to be thought of too, long before they start going vertical with the building. So, yeah, I could probably talk for.
I'm sorry, John. It's not me.
I think that, you know, we got to look at the solution as a wide-ranging solution. Like, you see, like the NY-GEO and stuff like that. You have parks that you're going to do refurbish. Why not drill loops in the parks before they do that? Why not have that base as the land that is open land, and drill that and use that later on for buildings you need to use. I think we have to think forward. You know, I think everybody thinks it's job specific. I think you got to think of the overall plan when you do stuff.
As we pass the mic down, I like to look at these projects and say, why isn't there a Starbucks here? Because my grandfather, being part of the greatest generation, he was really good at burying shit as well. And I think we have to think about man-made subsurface obstructions when we're doing these projects, because that is a significant piece there.
We're not on Manhattan. I don't know how you dare to go there and drill, Garrett, but it's we do have challenges also. So urban drilling is, for me, what you saw in the picture where we do deep drilling and angles. I think that can add solutions to the market. We're also doing inside buildings. Basically, we're using the same rig as you saw in the pictures, a Komatsu Geo 600. We just changed the mast on the drill rig, so instead of having 25 feet high rig, we can go under 9 feet, and we can bring that drilling rig to a basement. Is it for every project that we should do that? No, only when the driller needs a challenge, and that's the fun part of this job, when you can do those jobs, but I'm not coming to Manhattan.
I guess I'd like to try to respond somewhat to the, I guess, the challenges, if that was the initial question. But you know, I found a lot of challenges going into from the day one when it comes to the Chicago type neighborhoods, and then Brooklyn itself. Many more challenges because it's way tighter. No alleys, no sidewalks between homes. But I think I've solved a lot when it comes to smaller residential homes and buildings, both commercial, you know, residential as well. I just don't want to count out the idea that I'm at a different caliber or a different scale than my friends beside me. But we have actually overcome a lot of the cost challenges using the machine that we use, the fuel challenges, the exhaust challenges, and the noise, especially in parking. So that's what, when I came here, when I saw the streets and the tightness of everything, that's why we developed everything for the van. So that's one of the main reasons we've done what we have to deal with the challenges that we've dealt with.
Soren?
Sorry.
I mean, our rig does not fit in a box, but
A big box.
A big box, yeah. I mean, when the mast is down, it's just over 30 foot long, so you need some space to tram it around. But what we are trying to address is the productivity part of it. Looking at the numbers, the drilling cost on the geothermal projects are still very, very high. And we're trying to do our part of that equation by just increasing the productivity to be able to address that. Also, if you are more productive, you're shorter time on site where there's a contest for the real estate.
Next question.
Oh, hi there, Monty Graham, City University of New York. I'm just curious, we're rigging a box or for anybody. Did you analyze electrical capacity of those brownstones, and did you have to work with Con Ed to scale it? What about environmental due diligence, apart from what Garrett had to say about the barrels?
I'm currently doing 3 projects locally, and they already had load calcs for the buildings. They were already pre-engineered before we came in to do the loop field. I think they're all oversized when it comes to engineering, but that's so common when it comes to, no offense engineers, if there are any out here. But no, that's all taken in hand. We are going along with the initial engineered loop fields, sizes, as well as equipment. But I do think that the projects themselves can actually be considerably less money if they're actually realistically engineered. But we're going with what's planned in this case, and I don't plan on continuing that way. I've been engineering, even though I'm not a certified engineer, I've been engineering my own projects for 20 years. So, but yes, we are going along with load calcs. Anyone else?
Josh? Oh, sorry. She has the list.
quick question. Jason and Duran, focus first. Are in the coil rig. Like, how would it work so well in like hard rock like here in Manhattan? I think it's
We were more experienced drilling hard rock out of Australia. That's one big rock. So we were a bit more uncertain on how it would perform in some of the softer. To drill rock, we would probably not get 450. So drilling hard rock is, we have
Hello, guys. My name is St. Williams. I'm working with or they're already here and looking for more business. But I think when it comes to this particular topic, I'm really curious. Like, there's one company that I have that manufactures, makes, sells drill. The Mazamas and Fervors of the world, compared to more urban residential environments like the drill in a box, or I think Garrett over here, you were kind of talking about it. Like, is it the cost? Is it the environment that you're drilling in? Or is it just a matter of, I don't know, designing it and then selling it? And where do you come in the process?
I'll take it. Hughes Bit invented the bicone, which was used at Spindletop in 1901, and then the tricone came along in the 20s. And tricone technology, when it comes to oil and gas power generation drilling versus, our geo exchange, it's just how much money you want to spend on that bit. Because we got the folks from NOV in here, we got Colt McCarthy with Republic. There's plenty of people that will sell you bits. It's just quality and grade of PDC teeth you want for a PDC, or the type of hammer you're going to run or whatnot, is going to be the bit you put into the ground. And the more you invest in that tooling, the bottom hole assembly, the mud motor, even to Scott's rig, the bits that he chooses to have the best rotation and being able to do mud rotary at an effective rate, all come back to what you're going to invest in that tools. And I think that's a big piece of qualified contractors, is them choosing the right tools, and that's their scalpel. And they can be a surgeon brilliantly, or it can become a blunt hammer when we go the opposite direction. Anybody else want to take it away?
Geology. Everything's geology. So for us, we know our area. We don't explore too far out of anywhere else. So we know the North Shore of Long Island. We know Brooklyn over here. We know Rockaways over there, what bit we would use from the experience we got. So we do dabble and try different things. Like, hey, that bit's only $950 compared to $9. Do that because labor is everything. It's a labor-intense business where we are. So we're looking for the most efficient to get the most production out of that. But
inside buildings that are existing. Talk about building. How do you plan for flowing condition, gas, anything like that on a site like this, either from the engineering side?
Everything's about what the other guy. We'll wrap blankets around where we bring up the testers and we. Look, I've been drilling angles since the first day. On that job. And to me, the water hammer was the best technique and the safest technique to drill inside a building.
Your question was regarding maybe like methane pockets, that type of thing. Especially, we're typically not going through rock. We're usually in a small space. Oh, I'm sorry.
Getting the nasty gram again.
Well, maybe he's the only one who really went. Maybe 2 methane pockets of all the projects we.
From down here, we don't have a gas issue down here. If you're close to the coast and drilling, you can have flowing wells, but
Limited access rigs inside buildings or whatnot. In Michigan, like but being able to have that low even though we're little G geothermal, 500 feet, and we say, heck, let's do these 1,500-foot holes. But holes. That's where test holes are going to come back, and exactly what John talked.
But I saw they had a tricon
power what we call a positive length, and that's actually a hammer, and it's also the fluid there. Fluid inside the coil.
Yes. So and I guess just, what are, I think we're probably a ways from like seen in Sweden or something like that,
Permitted appropriately. A 100-year life cycle that we're looking at. In many states on this, and
Good. So when I need to check where over the years combined with, just I would love a database with but it's gonna take a long data that eventually could go into a database, but
with their Evo system. This knowledge opposed to, hey, there was a test port.
Databases that are being worked on, but conate waters that might be artesian pressure